This is the Oncozine Brief with Peter Hofland.
In this episode of the Oncozine Brief, I'm talking with Tim Blauwkamp. Tim is the Chief Scientific Officer and co-founder of Karius. Karius has developed a non-invasive liquid biopsy, a blood test, called the Karius Test. The test is based on next-generation sequencing of microbial cell-free DNA and can rapidly detect pathogens causing serious infections, including those diseases that are difficult to diagnose through conventional methods. The test can identify and quantify over 1,000 clinically relevant pathogens, including bacteria, DNA viruses, fungi, and parasites. Applications may include complicated and atypical pneumonia, infections in immunocompromised patients, including invasive fungal infections, viral infections, and neutropenic fever, and endocarditis and other cardiovascular infections. In the right patient population, the test is faster than conventional culture-based diagnostics and eliminates traditional diagnostic methods for deep tissue infections, which may require a diagnostic surgical procedure. But overall, the test helps clinicians make rapid treatment decisions. And this is especially important for infectious disease diagnostics in immunocompromised patients, including patients with cancer. According to the Centers for Disease Control and Prevention, each year about 650,000 cancer patients receive chemotherapy in an outpatient oncology clinic in the United States. And while chemotherapy is important for the treatment of cancer and hematological malignancies, it may also lead to a condition known as neutropenia, a dramatic reduction of white blood cells. These cells, called leukocytes, include B cells, T cells, and NK or natural killer cells, are designed to help fight infections. But when their numbers are reduced by the cancer therapy, infections may develop easier and can be harder to control. Infections may make treating cancer more complicated. And when infections develop, the medical team needs to eradicate the infection before they can start another cycle of chemotherapy or radiation therapy or perform any surgical procedure. Preventing or eradicating infections is vital to continuing a patient's cancer-targeted therapy. A complicated factor is that the medical team must also be on the lookout for side effects caused by the medication they use to treat the infection in patients who are already dealing with the side effects related to their cancer therapy. Without a doubt, patients receiving chemotherapy are at a higher risk for developing infections. In turn, these infections may lead to hospitalization, disruptions in chemotherapy schedules, or even death. The CDC estimates that about 60,000 cancer patients are hospitalized with infections every year in the United States. In fact, infections remain a primary cause of severe morbidity and mortality in immunocompromised patients. In some cases, more so than the morbidity caused by the cancer itself. I'm Peter Hofland, and this is the Oncozine Brief. The Oncozine Brief is developed in collaboration with our online journal Oncozine at Onco'Zine.com, where you can find additional information and the latest news about cancer, cancer diagnosis and treatment, and cancer prevention. For more information on how to support the program, visit our website at Onco'Zine.com. And if you're living in the United States and want to receive our newsletter, text the word cancer to 66866, and we will make sure that you'll receive our newsletter, which includes an overview of the latest news in oncology and hematology. Now let's listen to our interview with Tim Blauwkamp. Tim, welcome to the program.
Thank you. It's my pleasure to join you today.
Now, before we're going to talk about the Karius Test and what your company is doing, how are you, your family, and your coworkers doing under this threat of the COVID-19 pandemic that's going on now for the last couple of months?
Yeah, thanks for asking. It is quite a disruptive event, these pandemics across the world. We are doing overall, I think, very well, potentially even better than average, just because we're developing an infectious disease diagnostic, of course, and there's obviously a lot of attention being paid to the role that these pathogens play in not only our health, as we've always paid attention to, but we've now seen exactly what sort of worldwide economic impacts and societal impacts you can have when these infections get out of control. From that sense, it's been exciting to be working on the forefront here of such a hot topic right now. The company itself, of course, is we've employed all the different precautions to keep our employees safe. We're continuing to run our operations under these new guidelines, 6 days a week, delivering those results back to our customers as quickly as possible. But of course, everyone that can work remotely has now gotten accustomed to working remotely for the last 5 or 6 months or so.
Yeah, does that pose a problem? I mean, I can imagine that people in the laboratory are not necessarily being able to work from home, but I mean, in all other operations that are working, does that make it a little easier or more difficult? How does that work?
Yeah, it's a mixed bag like most things. For the people in the laboratory, we're a smaller company. We still consider ourselves a startup, and that makes us all pretty attached to the mission. And so people are generally willing to take whatever inconveniences are imposed or required to complete our mission in stride. And so our laboratory teams have been phenomenal in adapting to the new work environments and the new protocols we have in place to make sure that we stay safe and healthy when you have to be working on site. In terms of working from home, lots of people really enjoy this. In fact, many companies offer it as a perk. There's some downsides in terms of maintaining that connection that's so important for many companies, but there's also many upsides in terms of being able to join meetings on time, facilitate interactions at the drop of a hat. And now that everyone's used to these Zoom meetings, we find it actually pretty convenient to meet and discuss work-related topics this way. I think in the end, we're going to find it pretty efficient.
In my introduction, I referred to the fact that you are developing a liquid biopsy. Now, when we talk about liquid biopsies, the Oncozine Brief is a program that primarily focuses on oncology and hematology. People will probably immediately jump to the conclusion, this is a test to detect cancer. Now, one of the other things I mentioned is the fact that it is there to detect bacteria, viruses, and so it's a different kind of liquid biopsy. Can you explain a little bit more about that? I mean, how different is this? Is the technology different? Is it borrowed technology from the oncology space? Tell me a little bit about that.
Sure, yeah. We refer to our technology as liquid biopsy for infectious disease, and it does have many things in common with liquid biopsy for oncology. But as you mentioned, there are also many differences that make it a technically and application-wise very distinct. And so the whole field of liquid biopsy generally refers to the fact that there's information in blood from other sites in your body that is very informative about what's going on there. And in the case of oncology, of course, that's DNA fragments from the tumors or the other cancers that get released from the site of the tumor and can be circulating in your blood. And of course, those are detected by liquid biopsy applications, and they inform you as to the state of the cancer in some way. Liquid biopsy for infectious disease is very similar in that about 7 years ago, we figured out that the pathogens that are living in all the various locations they inhabit throughout your body also emit fragments of their DNA, which float through the bloodstream for a small amount of time until they're processed like all the other nutrients and waste in your bloodstream. And we developed a technology then to very sensitively pick up these fragments that are generated by the microbes in your body and understand whether the levels of those fragments are normal or abnormal. And by examining the identity of those fragments, figure out which microbes are causing disease really anywhere in your body from this information that can be found in a very standard blood draw.
That in itself sounds familiar to, I think, the oncology space, where we don't look for viruses or fungi, but we're looking for specific markers leading to a potential or diagnosing cancer. So in that respect, it's very, very similar.
Yep, exactly. And the concept of how we're approaching this non-invasive diagnostic for, in this case, infectious disease organisms is very similar to the non-invasive way you would characterize various cancers. That's been useful in a number of ways as well, which we can get into, but certainly such a new technology as either liquid biopsy for oncology or infectious disease faces a number of challenges, both in the development of the technology and the way that you assess its clinical efficacy and the regulatory pathways you use to ensure that quality. And we've been able to learn quite a bit from the progress that's been made in liquid biopsy for cancer. And that's been very useful.
Yeah, talk to me a little bit about those challenges, because first of all, the test that you do is new or relatively new. So when it comes to a new technology, there's always a lot of questions. Does it work? But what was the old process that you try to replace or add on to make what you do in discovering the viruses, the bacteria faster? And why was that necessary?
So physicians have been working on, and physicians companies, essentially the world has been working on ways to figure out what microbes are causing disease in our body for hundreds of years. And of course, those technologies are constantly evolving. Right now, most of those technologies still require a sample of the infected tissue or the infected fluid so that you can then take a closer look at what's in that infected tissue or fluid. And that means that when you get an infection that's localized somewhere in your body, such as a pneumonia localized to your lungs or a brain infection localized to your central nervous system or some abscess that's growing on an internal organ, you need to both know where that infection is happening and then surgically or somehow other invasively go in and get a sample of that infected tissue or fluid. And then you need to send the right tests on it to try to figure out what pathogens are in that fluid or that tissue. And of course, the pathogens that cause disease in humans are widely varied and include the things you've mentioned, such as the viruses, the bacteria, the parasites, the various fungi and molds. Most tests will only test for a handful of those at a time. And so if your first educated guesses about what's causing the disease aren't right, you'll need to send another test and another test. And you just currently you work your way down a list of likely hypotheses as to what's causing the disease and wait for a confirmation that you've identified the right microbe. And many of those tests take days to weeks to months. Since they require invasive procedures, they can be quite slow and iterative.
Let's take a break. And then we're back with Tim Blauwkamp. Tim is the Chief Scientific Officer and co-founder of Karius.
Clinical trials allow researchers to introduce new hope by providing participants access to cutting-edge and potentially life-saving treatments. Speak with your doctor and visit standuptocancer.org/clinical trials to learn more. Together, we can stand up for all of us.
This is the Onco'Zine Brief with Peter Hofland.
If you're just joining us, this week I'm talking with Tim Blauwkamp. Tim is the Chief Scientific Officer and co-founder of Karius.
Our approach, of course, takes most of those challenges that I've just mentioned out of the equation because blood, of course, surveys your whole body. And so you get information from every location in your body that has access to blood all at once. And when we use our next generation sequencing or our high throughput sequencing to analyze the information that's in blood, that means we can test for essentially every pathogen that could be causing the disease all in one shot. And that allows us to non-invasively get to the etiology or the cause of your infection much more efficiently than is possible with most standard of care methods today. And of course, that's at the heart of the clinical studies that we do to define and examine our value for patients.
You mentioned something when you are in the old ways of doing things and basically the standard of care for, in many situations still. You talk about an invasive approach, surgery, whatever it may be. But you also talk about, and that sounds a little bit ominous, is like that a educated guess by the physician team or the physician that's actually treating the patient. What if the physician is on the wrong track in the standard approach? You mentioned multiple surgeries, but when you look at infections, that may be a little bit of a problem because, of course, infections may need to be treated immediately. So what are the consequences of that old way of doing things?
Yeah, you're absolutely right that it is a great challenge sometimes to identify the cause of an infection. And the reason identifying that cause is so important is because we have a pretty good suite of antimicrobials or antibiotics at our disposal, but they all work on a different subset of the things that could be making us sick. And so getting as quickly as possible to that specific antibiotic that's going to very effectively treat your infection without causing unnecessary side effects like damage to your liver or kidneys is really important.
How does that benefit, in this case, the timeline in which to discuss things or to find things?
There's a couple of things that are super important when you're trying to get to that cause of infection, and timeline is one of them. And particularly when we talk about patients with cancer, getting to that effective therapy very quickly is even more important because most of these patients with cancer will have a compromised immune system and therefore not be able to fend off even normal infections as effectively as a person with an uncompromised immune system. And so we've done a couple of studies now, including one we published in Nature Microbiology. It's a very respected journal last year. Another one that's going to be coming out soon where we specifically examine the speed at which we're able to get to a true identification of the cause of disease versus the standard methods, or what you refer to as the old ways of doing things. And in both cases, 80% of patients were able to get to an answer faster with our technology than with the standard methods that frequently require these invasive procedures and often employ an iterative type of approach that works their way towards the different hypotheses that might be causing disease. The reason that's really important is because, particularly in patients with cancer, because the consequences of these infections are so severe, we're now moving to a scenario where most of these patients are getting preemptive antimicrobials against the things that are most likely to cause their disease. And that naturally means you're using very strong, broad-spectrum antibiotics that sometimes have very serious side effects in terms of potentially damage to your liver or your kidney. And though that damage is, of course, permanent and can affect which other drugs you're able to tolerate for the rest of your life. So the idea is to get off of those broad, more toxic antimicrobials as quickly as you possibly can and get to the very specific antimicrobials that typically have fewer side effects as quickly as possible so that you can minimize the long-term damage that both the infection and sometimes the cure to that infection would necessarily cause.
Now, you're talking in this case about cancer patients, even though the test, and let's specify this very clearly. The test that you do is not to detect cancer, but it is to detect the viruses, fungi, bacteria, whatever it is, the infectious agent in that respect. But you apply it or you use it in the case of a cancer patient who may be in a hospital and may have is immune compromised in a sense that their immune system may not necessarily work optimally because of the cancer and the cancer therapy, and yet then be more prone to infectious. Is that the right way to sum it up?
Yeah, that's exactly right. The technology itself works just as well in patients that have an infectious disease with an intact immune system as it does in oncology patients whose immune systems are typically compromised for at least some of their time with cancer. The difference is that the existing standard of care doesn't work nearly as well in patients with cancer. And there's a couple of reasons for that. First of all is they're going to get infected with a much wider variety of pathogens than what people with intact immune systems get. And that means the list of organisms that are likely to be causing their disease is much, much wider, and there are far more hypotheses to test in the old way. And so the value of testing for all of those at once is actually much greater in that sense. And as Ag mentioned, the consequence of not curing that infection in a person with an immunocompromised system can be much higher as those infections take much stronger hold when there's no resistance to them by your immune system.
If I understand this right, if you don't treat the infection in ways of a cancer patient being treated, it also becomes more difficult to treat the underlying disease, the cancer that is maybe causing the whole problem in the first place.
You're absolutely right there. That's another great point in that most protocols will require you to stop the chemotherapy if you detect an infection. And that's, of course, the right thing to do for the overall benefit of the patient, but it can compromise the effectiveness of that chemotherapy downstream. And so ideally, you want to get that patient back on their cancer therapy as quickly as possible by curing the infection that's requiring you to pause that chemotherapy as quickly as possible.
Now, let's talk a little bit further about the test, right? It is one of the things that I thought was a very large amount. You refer in the documentation about 1,000 bacteria, DNA, viruses, and I think even more so, fungi and etc. So that's a large number. In the old ways of doing things, obviously it might be very difficult to discern, what we were talking about earlier, how to find what is the underlying infectious cause. But in your case, with this particular test, you can find things easy. Is that correct?
That's correct. That's right. We test for essentially every known pathogen that has a DNA-based genome at once.
Right. So that makes your test very, very unique in the fact that you have so much you can test against. What also was remarkable, I think, what I read in some of the documentation is that it is fast. Within, I think, 24 to 48 hours, you can have the results from your lab into the hands of the physician.
Yeah, that's absolutely right. And this is one of the areas where the requirements for a diagnostic test using liquid biopsy are different for infectious disease than cancer. Diagnoses matter in every field, but in particularly with infectious disease, timing is critical. And so we really invested a great deal of efforts in not only as our top priority, the quality of our testing, as a second priority, the accuracy of our testing, making sure we can identify as many of the true positive causes of disease as possible, but also the speed of our testing. Now that does come third, but even as a third priority, where we're not making any trade-offs that would compromise quality or accuracy, we're able to get that turnaround time to roughly 24 hours from the time we receive the sample. During that time, we add a number of controls. We do our actual chemistries in the laboratory. We do all the sequencing, and then we apply our artificial intelligence-based algorithms to the analysis of all of that sequencing data, such that we can identify which microbes are producing abnormal amounts of this microbial DNA in the bloodstream.
Let's take a break. And then we're back with our interview with Tim Blauwkamp. Tim is the Chief Scientific Officer and co-founder of Karius. Karius has developed a non-invasive liquid biopsy, a blood test, called the Karius Test. The test is based on next-generation sequencing of a microbial, cell-free DNA and can rapidly detect pathogens causing serious infections, including those diseases that are difficult to diagnose through conventional methods. The test helps clinicians make rapid treatment decisions. And this is especially important for infectious disease diagnostics in immunocompromised patients, including patients with cancer. I'm Peter Hofland, and this is the Oncozine Brief.
The Centers for Disease Control and Prevention is encouraging cancer patients and survivors to be extra cautious during the COVID-19 pandemic. Cancer treatment, especially chemotherapy, weakens the immune system, making you at higher risk of severe illness. Dr. Lisa Richardson is director of the CDC's Division of Cancer Prevention and Control.
Take these steps to stay healthy. Wash your hands often with soap and water. Clean and disinfect frequently touched surfaces daily. Stay home. If you must leave, keep at least 6 feet between you and others. Avoid touching your face, eyes, nose, and mouth with unwashed hands. If your temperature is 100.4 or higher, call your doctor. Use CDC's coronavirus self-checker to help you make decisions about seeking medical care.
Make sure your caregivers and household members are aware of your higher risk and take precautions. Visit cdc.gov/coronavirus and preventcancerinfections.org for more health tips.
This is the Oncozine Brief with Peter Hofland.
And welcome back. I'm Peter Hofland, and this is the Oncozine Brief. Based on the amount of information that you'll be able to gather to basically put together in a report for the physician, what you're doing, does that include, for example, not only the diagnostic, but also a potential treatment approach?
Yeah, so that's actually where we draw the line. We identify the pathogen that's causing disease at the species level, which in and of itself is sufficient to pick the appropriate therapy for the vast majority of different types of pathogens that could be causing infection. Now, we don't go the extra step and say this is the most effective antimicrobial to use on this pathogen. The physicians, and in particular the infectious disease physicians, are still a fundamental part of this process of diagnosing infectious disease in the patients. And they play roles in both interpreting the information that we give them and then deciding what therapies to apply based on that information.
But it is a collaborative effort in that respect.
Absolutely. Yeah, we partner very closely with infectious disease physicians and oncologists in providing the best care for the patients that are using our test.
You are in clinical trials with your test, a study to make sure that the test works optimally in oncology, I believe. Now, you do that within pneumonia, I believe. Tell me a little bit about this test. I guess it is called the pickup test or pickup trial. Tell me a little bit about that. What have you found so far?
We actually have quite a diverse portfolio of clinical studies that we're employing. Clinical studies, of course, can vary in how big they are, which generally correlates how confident you're going to be in the results. And so we've applied our technology within clinical studies over at least 10 different applications and over the last 6 years or so. One of the things we're finding as we look at all the different ways that the technology can be used is that it is particularly useful relative to the alternatives in immunocompromised patients that contract pneumonia of some sort. And so the pickup study itself is designed to specifically explore the role that our test can play in immunocompromised patients with pneumonia relative to the standard of care tests. And we've applied our test to the same type of scenario in a variety of smaller studies and been very encouraged by both the ability to see things faster than the standard of care, the ability to see things that the standard of care would miss that are important for the patient's care. And even in a study we did with Rady Children's, our ability to improve the antimicrobial regimen for 47% of the patients that were enrolled. Now, most of these studies are much smaller, and so Pickup then is designed to be a very convincing landmark study that informs the population as to just how useful this test can be. And so we've enrolled 10 different study sites, including all of the premier cancer institutions across the U.S., and we plan to study the role of our test compared to every other diagnostic test that could possibly be used on these patients in aggregate for about 200 patients over the course of the next year. And so we recently announced first patient in and active enrollment. We're able to maintain at slightly diminished speed the enrollment at a couple of sites through COVID-19. Many sites were justifiably and appropriately preoccupied by treating COVID-19 patients and figuring out what those protocols are going to be. It seems that most institutions now have figured that out and are restarting the enrollment for a variety of other clinical studies that are going on there. And so we're very happy with the progress we're making on the Pickup study enrollment now and hope to have a readout in the not too distant future.
Yeah, I think I spoke to somebody else earlier this week talking about clinical trials. Cancer doesn't stop because of COVID. And so while clinical trials may be slowed down because of a lot of emphasis going to COVID, it's still important to diagnose and test patients who are in the hospital or in some care facility for their cancer, potentially impacted by infectious diseases. So I'm glad that your recruitment of patients, even though maybe slowed down a little bit, definitely is on track to meet the needs of those patients. That's actually good news. Is there anything that you changed in trying to recruit patients as a result of COVID, or maybe in the operational ways, how to deal with physicians and COVID and cancer and infectious diseases? Did that change or not?
Absolutely. And I wouldn't call them transformative ways, but certainly monitoring the quality of the study, which means basically having a series of double checks or triple checks on the information we're collecting or the types of patients that are having access to the test is frequently done in face-to-face conversations through site visits. All of that has now shifted to remote monitoring, and therefore you use different types of double checks and triple checks on the quality of those studies. And so we've and I presume everyone else who's doing these larger clinical studies has had to identify some new ways to ensure the same level of quality when you're not on site. But once you figure that out, you have now a new system that can potentially be even more efficient than the old system. If there's no impetus to change, generally people won't. But, when there is an impetus to change, sometimes you can find even better ways of doing things. And I think that's going to happen in a lot of different areas following this COVID-19 pandemic.
Yeah, I think a lot of people are considering how COVID may have impacted and the good things of changing certain ways of working and how to retain them after COVID is gone. I think that's probably also the case in what you guys are doing.
Yep, absolutely.
If people want to know a little bit more about the pickup study, and if there is a physician, an oncologist or hematologist that listens to the program and says, hey, we are not on that list of institutions, or we would like to, or we part of that, how can I get more information? If a patient or a family member of a patient listens and wants to know more about this particular trial and how that potentially benefits their loved ones or themselves, where can they find more information?
If you're just curious about the trial, you can find information about the pickup trial on clinicaltrials.gov. We put all of the basic information there. We're partnering very close with Duke University on this study. And so you can contact us at kariusdx.com. You can contact me personally to learn more about the trial if you'd like. And we can put you in touch with the PIs or the principal investigators at Duke University as well. We're on track with this particular study to finish enrollment at the time that we anticipated. We don't want to necessarily extend the enrollment beyond that because, of course, the readout of the study is where we learn exactly how to best apply this test to various cancer patients. But we do have a healthy pipeline of several additional studies in very similar populations. And so if one of your listeners does want to learn more about either the pickup or in opportunities that are emerging in similar applications with other studies, I'd be more than happy to talk about those other studies as well, which are still both forming and actively enrolling. And so I'm sure there's a way to fit most inquiries into an enrollment.
When do you expect the results of this particular study, the pickup study, to be finalized and be presented? And where are you going to present them?
We're still figuring out the exact timelines in light of the COVID-19 slight delays and the rates that our institutions are picking up again. And so I'd rather not put a benchmark in the sand yet, but I hope to have a readout within the next year. Where we're going to present that will depend a little bit on what the most appropriate venue would be, given the timing of the readout itself, when we're finished with enrollment and analysis of the test.
In the meantime, people can find information from your organization and the company and maybe from the team at Duke to see what's going on. We mentioned COVID in this program quite often. Normally, we're only focusing on cancer. I think COVID is almost the second part of this program right now. I understand that the Karius Test also plays a role in COVID. It might be very important during the upcoming flu and pneumonia season. Tell me a little bit about that.
It's hard to exist in the diagnostics or probably even the medical world without integrating some strategy as to how you're going to either react or help with the COVID-19 pandemic now. And very early on as a diagnostic company, of course, we were faced with a question of how we were going to participate in addressing this pandemic. Now, the test that we offer right now detects DNA-based organisms, of course, and the coronavirus that causes COVID-19 is based on an RNA genome. And so we don't actually detect that specific pathogen with the current test. That being said, there are many diseases that present with similar symptoms to COVID-19, including the flu, as you mentioned, and serious pneumonia. And it can be very difficult to identify which organism, whether it's COVID or one of the organisms that cause the flu or pneumonia, is causing those symptoms. And so we're able to play roles in that same population, both in the patients that ultimately test positive or negative for COVID-19, including our ability to identify the true cause of infection in those patients that present with those symptoms and are COVID-19 negative, and our ability to identify co-infections in the patients that happen to have happen to be COVID-19 positive as well. And of course, many of those patients are found in the hospital, and that's primarily where we apply our technology. And so it provides a convenient way to, when a patient is COVID-19 positive, not have to transport them throughout the hospital to all the different wards for all the other different invasive procedures, which increase the risk of transmission when you can test them for every other pathogen through a blood test like ours.
Right. So it is actually speeding up testing, speeding up the results that come out of that, although not necessarily testing for the SARS or COVID-19 disease combination. It's focusing on what else is going on to make sure to rule out the other problems that may exist.
Yeah, absolutely. And helping hospitals with their transmission reduction policies by not having to transport these patients throughout their system.
Yeah, I think that is, especially with the pandemic that we see right now, that's a crucial step in benefiting patients and also the systems itself. Let's take a break, and then we're back with our interview with Tim Blauwkamp. Tim is a Chief Scientific Officer and co-founder of Karius.
Sarcoma. Odds are you've never heard that word before. But for the 40 people diagnosed with sarcoma every day, it is a life-changing word. Life-changing and devastating because sarcoma is cancer. Sarcoma is a cancer of bone and soft tissue more prevalent in children than in adults. More than 6,000 people lose their lives to sarcoma each year. Treatment options for sarcoma are limited, and new therapies are desperately needed. More research and increased awareness is necessary to find a cure for a cancer that you probably didn't even know existed until now. Through awareness, advocacy, and research, the Sarcoma Foundation of America is determined to help those affected by this forgotten cancer, to bring hope to the children and adults whose lives are forever changed by a word they had never heard before. Please help us in the fight to find the cure for sarcoma. For more information on sarcoma and the work of the Sarcoma Foundation of America, please go to curesarcoma.org.
This is the Onco'Zine Brief with Peter Hofland.
If you're just joining us, this week I'm talking with Tim Blauwkamp. Tim is Chief Scientific Officer and co-founder of Karius. One of the things is that this pandemic is not the first one. It's also not the last one, most likely. How are you prepared, or how can healthcare systems or patients or hospitals benefit from your test to potentially prevent outbreaks of pandemics in the future?
Maybe I'll briefly mention three different mechanisms that I think help, because this is obviously at the front of everybody's mind right now. We'll probably start at the smaller scale, and while not at the scale of a pandemic, many infections that patients who are hospitalized get actually start in the hospital themselves through these so-called hospital-acquired infections. And those infections, of course, are typically from related microbes. And so many patients might get might get infected with the same strain of a particular pathogen. Just like humans differ in their genetic makeup, even different populations of the same pathogen can differ slightly in their genetic makeup. And that allows us to, when we look at their information, at the genetic information from that bug, we can tell which population that particular patient's infection came from. And in that sense, identify whether an infection originated in the hospital or likely originated outside the hospital. And that helps hospitals with their ongoing quality control efforts to limit the spread of infections within the hospital setting itself. And so, obviously that's not a pandemic or even an epidemic, but it is at the top of mind for many institutions because reimbursement rates can be affected, reputation can be affected. And so by being able to help hospitals limit their transmission, by identifying when it happened and potentially even where within the hospital system those infections are occurring, we can help improve the downstream outcomes for the patients that those hospitals serve. Maybe a second dimension has to do with the antimicrobial resistance that generally emerges. And of course, the more resistant a microbe is to being killed by our antimicrobials, the more effectively it's able to spread within a population. And just because many infections are still very hard to diagnose, we often have to employ these preemptive antimicrobial therapies. And whenever you're treating microbes that are not the very specific cause of that patient's infection, you're increasing the risk of antimicrobial resistance developing across a variety of other pathogens. And so by very efficiently identifying the cause of infection, we can limit the use of these unnecessarily broad antimicrobials, which in theory, at least, though we've never proven it, and I'm not sure exactly who would be able to prove it, limit the generation of antimicrobial resistance throughout the world. And of course, those same principles can be applied globally. One of the nice things about testing patients for everything that could be causing their infection is with our approach, you can very easily see which microbes are causing the most problems in that patient, but you get a snapshot of stuff that might be happening in the background as well. And you get that for every patient you test, which means that you have a real-time view of all the microbes that could be causing disease from every patient you test. And when you attach that to the location at which the patient is being tested, you can develop this map of the relative abundance of different microbes throughout the world. And you can track that over time and see what microbes are increasing in prevalence, how they're moving through space. And if you're able to get to their differences in cousins, let's call them, you can even tell which particular populations of microbes are spreading faster relative to the other populations of microbes. And that, of course, allows you to optimize where your resources are deployed, how frequently you're testing for different things. It can help physicians who are still using hypothesis-based approaches make better hypotheses in a geographically specific way. And so I think this whole approach of just testing for everything is really going to have a number of ways that it can help with limit these pandemics or these epidemics or even these hospital-based spreads of organisms.
And that is not necessarily only at hospital level, but it can be on a much broader level in that respect. Technically speaking, if you look at the number 3 system that you just mentioned, when you see certain things happening in a certain area, it allows you to push the alarm bell, right? Or ring the alarm bell. Now, some of the things that we may not have discussed about the Karius test, some of the key things that people should know about the test, the benefits. I think we covered a lot of different aspects. But one of the things what stands out in your mind as where the Karius test, and not only this particular test, but maybe similar tests over time may take us. But again, you've taken out technology out of a different environment and applied it to some completely different application. Where are we going with this?
Obviously, as one of the founders of the company, I drank all the Kool-Aid it's possible to make in terms of just how powerful and disruptive I think this technology can be for improving patient outcomes and empowering physicians to provide the care their patients need far more efficiently. If I were to just summarize what I think are the major differences with our approach relative to the best available care outside of our approach now is the current methods generally have lower than desired rates of identifying the specific microbes that are causing disease. We know that blood culture, for example, which is one of the most common diagnostic methods possible, identifies the etiology of disease less than 20% of the time. In patients with pneumonia, the entire spectrum of diagnostics that are employed still fail to identify the cause of that pneumonia in about half the cases. And the same is true in sepsis, one of the most intensively studied infectious diseases that we're aware of. And so, despite the phenomenal training and application of existing tools by infectious diseases, there's still lots of room to improve the care for patients that succumb to an infectious disease. And the challenges there are always the same. You have to find the location of the infection, get a sample of that fluid or tissue to test, and then send the right test among literally thousands of options to see if your best hypothesis is correct, and then to see if your second best hypothesis. We use that information in blood to test for an infection anywhere in the body, and we use that sequencing to test for anything. And in that way, we're able to provide just an overall much higher diagnostic rate in an overall much faster time frame across a wide variety of patients. And it just so happens that with pickup, the existing technologies are especially challenged in immunocompromised patients. And so we're focusing some of our first applications on the greatest need with those patients. But the technology itself works just as well in a variety of different patient types. And so non-invasive testing that can test for everything in 24 hours, I think will undoubtedly find its place in routine diagnostics as the clinical evidence to prove its effectiveness accumulates. And that's really what the pickup study and several of the other studies we have going on are meant to do. Prove that effectiveness so that physicians are comfortable applying this amazing new technology in their patients.
In summing up, would it be fair to say that you take the guesswork out of testing for infectious diseases, not only take out the guesswork, but also make it more patient-friendly, so ease of use in that respect? And your faster turnaround would potentially lead to a less aggressive disease with patients. Are these things, to sum up, correct?
I couldn't have said it better myself. We take the guesswork out of which tissues to test and which pathogens to test for, and that results in better care for patients.
Thank you very much for your time with us. We're definitely going to hear from you in the future. Thanks very much for joining us here at the Oncozine Brief.
It was my great pleasure to talk with you today, Peter. Thanks for inviting me.
In today's edition of the Oncozine Brief, I spoke with Tim Blauwkamp. Tim is the Chief Scientific Officer and co-founder of Karius. Karius has developed a non-invasive liquid biopsy, a blood test, called the Karius Test. The test is based on next-generation sequencing of microbial cell-free DNA and can rapidly detect pathogens causing serious infections, including those diseases that are difficult to diagnose through conventional methods. In the right patient population, the test is faster than conventional culture-based diagnostics and eliminates traditional diagnostic methods for deep tissue infections, which may require a diagnostic surgical procedure. But overall, the test helps clinicians make rapid treatment decisions. And while this is important in many different patient populations, rapidly diagnosing infections and understanding the causative pathogen is especially important in the treatment of patients with cancer. For more information about Karius and the Karius test, visit the company's website at kariusdx.com. That is KARIUSDX.com. For us here at the Oncozine Brief, we want to thank you, our listeners, sponsors and advertisers, for your ongoing support. Your support makes it possible that you can hear this program via PRX Public Radio Exchange and in the United Kingdom and mainland Europe via UK Health Radio. And you can also download the program via podcast and streaming media, including iTunes and Spotify. For more information about supporting the Oncozine Brief, go to Oncozine at oncozine.com. If you're living in the United States and want to receive our newsletter, text the word cancer to 66866, and we will make sure that you'll receive our newsletter, which includes an overview of the latest news in oncology and hematology. Thank you all, and thank you for listening. And join us again for our next episode. I'm Peter Hofland, and this is the Oncozine Brief.
The Oncozine Brief is produced for Sun Valley Communication by Peter Hofland, Sonia Portillo, Evan Wendt, David Kaler, and distributed by InPress Media Group. Support for the Oncozine Brief comes from listeners of this station and our commercial underwriters and advertisers. For more information about underwriting and sponsoring options, visit our website at oncozine.com/underwriting. The Oncozine Brief contains health and medicine-related information and is provided for educational and entertainment purposes only. The content is not intended as a substitute for professional medical or health advice and does not replace your doctor's advice. Your doctor is the best person to answer questions about your personal health. If you hear something in this program that doesn't agree with what your doctor has told you, ask him or her about it.